All right. Hello and welcome everyone to our office hours webinar for BrainHQ. We're so glad that you could be joining us today. My name is Stephanie and I'm a member of our customer delight team here at Posit Science. Now, today's format is going to be a little bit different from our previous office hours webinars. So let's take a look at the agenda for today. So in customer support, we get a lot of questions about a few exercises in particular. So Henry and I are going to be teaming up today to go through those exercises step by step and then demo those exercises for you. The exercises that we are going to be primarily be talking about today are double decision, right turn, optic flow, and face-to-face. Now, if at any point you'd like to ask a question, you can click the Q&A button on the Zoom control panel and a new window will pop up. You can type in your questions there and then we'll do our best to answer as many of those questions as we can. Now, try and keep your questions related to the exercise that we are currently demoing. So if we're demoing right turn, try and keep questions to right turn. Now, we'll do our best to leave some time at the end of the demo for questions about any other exercises. Now, there are a lot more of you in the audience than there are me and Henry, obviously. So that means that we aren't going to be able to answer every single question. But good news is that you can send any follow-up questions that you might have to our support team. Our email address is support@brainhq.com. We also have a support site, which you can find, support.brainhq.com, that will have answers to a lot of common questions. Now, the other thing that I wanted to note is that today's webinar is being recorded and it will get posted to our YouTube channel in the coming days. So if you would like to be notified when that video goes live, you can go to youtube.com/brainhq and subscribe there in order to receive a notification. You can also find a recording of last year's Challenge On webinar there too. Last year, we went over True North, Rhythm Recall, Card Shark, and Mindbender in a lot of depth. So if you'd like to see demos of those exercises, we would absolutely encourage you to go watch that recording. All right. So I mentioned him earlier, but joining me today is going to be Dr. Henry Monka. Henry, you want to say hi?
Hi, folks. Hi, Stephanie. Delighted to be here and talk about these very cool but slightly complicated exercises.
Absolutely. Henry, for those of you that don't know, is a neuroscientist here at Posit Science and also our CEO and has been CEO here for quite some time now. So we are going to be tag teaming this webinar for you guys today. All right, so let's go ahead and dive right in. Let's start by talking about double decision. So double decision is an exercise from our attention category. So it's designed to enhance visual processing speed and improve how accurately and quickly someone can see details. This includes being able to notice features in your periphery when you're looking straight ahead. So the size of this area that you can see is called a useful field of view. Sometimes we call it UFOV or UFOV for short. So why is it important to train your visual processing skills? Being able to accurately see and react to objects around you is actually really, really important. So for example, you need to be able to see and process information quickly and efficiently when you're doing things like crossing the street, walking up and down stairs, cooking a meal, reading a book, driving a car. It's a very big and integral part of our everyday lives. Now, if you have poor visual processing, it can make it difficult to do those things safely and efficiently. So double decision specifically challenges a person to simultaneously look at an object in the center of their vision and then also in their periphery. So let me take you through this step by step, and then we'll go to a live version of the exercise. All right. So when you first load up a level of double decision, you're going to be shown two vehicles towards the middle of the screen. So here we have a car, and then we have sort of a box truck. Now in the periphery in this highlighted section, we have a Route 66 sign. Once we've taken the time to take a look at the differences between the cars or the vehicles, we can go ahead and click on Start. Now, a vehicle and the Route 66 sign are going to appear on screen at the same time. The vehicle is going to be in the middle of the screen, and the sign is somewhere off to the side. So in this case, we have that box truck in the middle, and then we have the Route 66 sign at roughly 4 o'clock. Now, these items are only going to be on screen for a short period of time. So our challenge is to quickly identify what kind of vehicle is in the center and where in the periphery the sign had appeared. Now, the items are then going to be covered by some static that appears on the screen. And this has to do with image ghosting, I believe. Henry, can you speak to that a little bit and maybe sort of the design behind that?
Yeah, you're exactly right. The exercise is a little bit, it's made more difficult by this. And what we're trying to do is we're trying to erase that sort of after image that can be in the eye on the retina after you see something. So if we didn't have this, the exercise would be a little bit easier because you would have that after image of the car or the truck in the center and the road sign on the side. And we want to make sure your brain is processing information as fast as possible. So that's why we insert this.
Yep. And not to worry, the static isn't going to be on screen for all that long. After the static disappears, you are going to see both vehicle options on the screen. So when you see the screen with the two vehicles, this is an invitation to select the car that you saw appear in the middle of the screen just a few moments ago. Now, we saw the box truck before, so we'll go ahead and select it. And because we got that right, now we can select the portion of the screen that the Route 66 sign had appeared in. So we'll go ahead and highlight that, 4 o'clock section of the screen and click, and there you go. So let's see what this looks like actually in real time.
Stephanie, before you go on to real time, can I say one or two more things about it? Do you mind
going? Oh, please do. Yeah.
Yeah. Do you mind going back to the beginning of the slides? I just want to highlight one or two things that I've heard people say is confusing for them. Thanks. Right here. So as it starts off, exactly like you said, I just want to emphasize that here it's going to show you both of the things you might see in the center, the car or the truck. So you see two of them here, and that's just to kind of inform you, what are you kind of looking for and what's the difference? So it's a good idea to look at the screen for a minute and really try and cement in the difference between, in this case, the car and the box truck. And then if you go on to the next slide, I just want to emphasize that here during the fast part, you're only going to see one of those two things. Some people get confused because they saw two of them originally and then they only see one here, but that's exactly what you're supposed to be doing. And here you're supposed to, of course, notice whether this is the box truck or the car. And then if you go on one more and then one more, now here you see two of them again. And of course, that's because we're asking you which one you saw during the quick part. So I wanted to just go through that because occasionally I talk to people who are a little bit confused about why on some screens they see two and on one screens they just see the one. I hope that was helpful.
Yeah, absolutely. And it's a very good point to clarify there because, like you said, it is a very common question that we do receive. All right, so let me go ahead and switch over to my demo window here. All right, and you should be seeing double decision on screen now, correct?
Absolutely.
All right, fantastic. So again, just like in the example, we're working with this sort of soft top car and a box truck and a Route 66 sign. So let's go ahead and click start. We got a vehicle and a sign in the periphery. Now we see the two vehicles. If I saw that correctly, I believe it was our box truck that was in the middle. Got that ding sound, so we got it right. And I believe our Route 66 sign was up here. There we go. So we know we got it right because we got that little ding sound and we saw the little fireworks show. I'll go ahead and do another trial here. So I believe that center car previously was the soft top here. And I don't quite recall where the Route 66 sign was because I was talking in the middle of that, but let's go ahead and guess. So that worked out nicely. Now, one thing that I also want to point out is that one of the things that trips people up is that there are sort of, since there are it's a two-step answer process that also gives you more opportunity to get a question wrong. So for example, you could answer which car was in the middle of the screen incorrectly, or you could answer which part of the screen the roadside had appeared in incorrectly. So for example, if we get the wrong car, we see the correct car and then the placement of the correct sign. Just like that. Now, let's say we get the correct car. We saw that it was a box truck in the middle of the screen, but we didn't quite catch where the road sign was in the periphery, so we go ahead and guess. It will still show us exactly where the road sign previously was. And I'll go ahead and do that one more time. Soft top in the middle, and then a wrong answer here. And we can see the Route 66 sign appearing up there. All right. So let me go ahead and switch back over to the presentation because I do want to take a moment to talk about how double decision gets more difficult over time. So one of the things that you may notice is that the vehicles will change from level to level, and some of those vehicles can get pretty similar to one another, which can be a very difficult thing to notice, especially when the vehicles are appearing on screen for shorter and shorter amounts of time. The next part is backgrounds can differ. It's much easier to see a blue car on an orange background, like we just saw, than it is to see, light blue cars on sort of a cityscape, as we see in this bottom image here. Road signs, a big part of this exercise, can also be either around the center of the screen, but eventually they make their way out to the periphery of the screen. So that's going to push your brain to try and focus both simultaneously on the image in front of you and even further out to the sides. Speaking of road signs, not only are there going to be different kinds of road signs that are going to show up in these levels, but the amount of road signs that are visible will also differ from level to level. So there are quite a few different ways that double decision can get more complex over time. All right, so I want to go ahead and start taking a couple of questions about double decision now. Henry, are there any that have been jumping out at you yet?
Well, there were one or two people who just said, hey, it gets very fast. And the answer is yes. Yes, I'm afraid it does get fast, which is why we're talking about it today. It's a challenging exercise. But it's getting fast because, of course, we want to train your brain to be faster. And hey, if you feel like it's getting too fast and you just have to guess, that's okay. If you get one wrong, as you kindly showed us, Stephanie, that's okay. It'll slow down for you afterwards, after you get one wrong. And of course, always in BrainHQ, it'll speed up as you get them right and slow down as you get them wrong. And that's the way BrainHQ works. That's how it finds exactly the right speed for your brain. So if you find it's getting very fast, don't worry. It's working exactly as it's supposed to. It'll slow down if it gets too fast for you.
Yep, absolutely. The adaptability of the BrainHQ exercises is a core tenet of the design principles behind the exercises. So definitely don't be afraid to get them wrong. That will tell the program itself to slow down to have you training in sort of a sweet spot for you. Sue has an interesting question, and Henry, I'm going to go ahead and toss it to you. I love facts and science. What studies have you done to show the impact of this exercise?
Well, double decision in particular has been part of quite a lot of beautiful scientific studies. And in fact, one of the largest studies of brain training that's ever been done was organized by the National Institutes of Health, called the ACTIVE study. And this double decision exercise was one of the cognitive training exercises used in that study, and showed quite beautifully that it helps the brain get faster and more accurate and improves processing speed, exactly as you lined up. But then, as you also talked about in that study, showed quite beautifully that it helps people be faster at everyday skills, sort of the ordinary flow of information that we have to keep up with as we go about our lives. And actually helps improve other aspects of brain health by, for example, helping people maintain independent living skills for a longer period of time and even stay in a more healthy mood for a longer period of time. And all that goes to just speak about how important kind of this basic training of visual speed is. Oh, and I guess I should also say quite clearly showed that it reduced the number of at-fault car crashes that people had over a number of years. So exactly as you said, Stephanie, by making the brain faster and more able to notice things in the peripheral vision, people actually stayed out of trouble on the road more often. So quite a lot of studies around that exercise in particular.
Yeah, absolutely. Lots of science behind that exercise. If any of you are interested in reading up more on that, you can go to brainhq.com/about, and we have a whole section on our site dedicated to the science behind the exercises and links to all of the research papers that have been done looking into the efficacy of BrainHQ.
Great.
All right, so I know we have a couple more, but I do think I want to move on to right turn because I'm seeing more questions about right turn, and that's up next in our agenda for right now. Okay, so let's talk about right turn. Now, right turn is an exercise from our navigation category and the first of two that we're going to be going over today. So in right turn, there are going to be two images that are placed side by side, and then one of the images is rotated relative to the other. So your task is to decide if the images are identical images or if they are mirror images or reflections of one another. So this is going to require you to mentally rotate the images in your mind. So why is mental rotation important? It's an important component of navigation, as the category suggests. Imagine navigating your way to a new store in an unfamiliar neighborhood. You need to be able to figure out how to get there, how to navigate the store, how to get out of the store, back to your car or the bus, whatever the case may be, and then back to your home destination. So this is going to require you to mentally rotate a mental map of the scene so that way you are heading in the correct direction. Now, Henry, can you talk to us a little bit about the science of mental rotation and why we've sort of included this exercise in BrainHQ?
Yeah, it's because there's actually been an astonishing amount of research on mental rotation over the past several decades. And it seems like kind of an obscure topic at first, right? I look at these two shapes and try to figure out if they can be superimposed or if they're mirror images. But cognitive scientists have been studying it for a long time, and it turns out it does relate to a lot of other cognitive abilities. And in particular, it does relate to navigation abilities. In the sense, you might imagine, you're looking at a map and, you need to figure out which way is north, but then you're looking out at the world and you're not actually looking north. And in your mind, you need to sort of rotate the image of the map to figure out which direction you needed to go in order to get where you're going. So it turns out that exercising that kind of that core cognitive skill of mental rotation, taps into a lot of important real world abilities, but certainly including navigation.
Yeah, absolutely. So it is definitely an important exercise to be training with. And so that's why we're happy to be able to take the opportunity to go over it today. All right, so let's go over the steps for right turn one at a time. So this is our first trial, and we have these two sort of Tetris images on either side of the screen. So like I said earlier, our task is to determine if these images are identical to one another or if they are instead reflections of each other. So after some time, what will happen is the images will disappear. And even though the images were on screen for a short period of time, we can still take as much time to answer as we need. Now, once we have made a decision, we can select our answer. So I believe in that case, it was the same image. There we go. And then what will happen is when we select that answer, we will see that answer reflected on the screen. There you go. So we can see that image rotated, so that way we can confirm that those are actually the same image. Now, this can be a place where some people will get tripped up. We often get messages from users that are confused about why the shape on the right turned a certain way. If the exercise is called right turn, then shouldn't the shape turn to the right? Well, no. When we talk about the title right turn, it's better to think of it as right as in correct instead of right as in the opposite of left. So think of it as correct turn instead of right turn. You have to basically be turning the image correctly in your mind in order to be successful with this exercise. All right, so let's go ahead and head over to a live demo of right turn here. So let's go ahead and hit the start button. All right. So there are a couple of funny tips and tricks that I like to do when I'm training with right turn. Sometimes I like imagining the shapes as they sort of relate to different features on my hands. And then I will try and rotate my hand to see if it is a reflection like a bookmark or if it is more, or if it is an identical image. Henry, do you have any tips and tricks for training with right turn?
What I usually do in my mind is I try to rotate it first, and I'm usually looking for a particular feature. Like on that one, there's that little tiny stub, and I try and rotate it in my mind, and then see where the rest of the part of the item line up in that point. And if I can't get it quickly, then I try to swap over to see, well, is it true that if I just flip it, it'll work? But I guess really the way I do the exercise is I try to rotate it first, and if I don't think I can rotate it, then I go ahead and guess that I should flip it. That's the best way to put it.
Not a bad way to go about that. All right, so we've seen a couple where we've gotten the question correct here, and the images are starting to appear on screen for less time than before. But let's talk about what happens when we get an answer wrong. Well, I should get an answer wrong first, is what I should do.
You're just
Okay,
too
so that
good,
one is
Stephanie.
it's just so good. Can't turn it off. Okay, so that one was definitely a mirror image. So if I go ahead and click on same, we still see that image rotate, so that way we can see the correct answer. We can see why that was a mirror image after all. Now, the other thing that I wanted to mention is that instead of using the mouse cursor to click on same or mirror, you can actually use the keyboard to give your inputs if that's easier for you. So if you wanted to say that that was the same, you would press the left arrow key on your keyboard. Or if it was a mirror image, then you would press the right arrow key on your keyboard. I got that one wrong, but anyway, the case stands. You can use your arrow keys on your keyboard to make that selection. All right, let me go ahead and switch back over to our PowerPoint here. So there are a couple of different ways that right turn becomes more challenging over time. You know, in the earlier levels, you're going to start out with sort of these Tetris looking pieces with really obvious blocks that you can sort of count out and figure out how they move around. But in later levels, you might have items that are pretty much identical to one another, except for maybe some shading differences. So that can definitely be a challenge when training with right turn. Now, the time that you have to compare images is also reduced. So those little clocks coming on screen is actually just it's basically just me whenever I'm training with right turn in real time. It's, you know, start out happy when it's nice and slow, get a little bit surprised when it starts speeding up, and then maybe get a little too anxious when it starts getting a little too fast there. The other thing that may happen is that you may be asked to fill in the blanks. So instead of there being pieces that are mirrors of one another, sometimes one piece would fit inside another piece, or maybe it is a reflection of a piece that would fit inside another piece. So the kinds of mental rotation that you have to do are different in some of those levels as well. All right, so let's take some questions about right turn. I know we definitely had some coming in early too.
I did see one question about published studies around right turn, and you know, right turn's a newer exercise, so there aren't any studies that use right turn only, but a number of studies have used right turn as part of the entire suite of BrainHQ exercises. For example, Stephanie, of course, you know our colleague, Dr. Q Lee, and she recently completed a wonderful study that was done in Iowa and Texas and actually looked at brain imaging, so how brain activation patterns train after training. And in that study, she used a pretty complete suite of BrainHQ exercises, including right turn, and showed these beautiful changes in brain activation, brain connectivity as a result of BrainHQ training. And I think that's typical in general of how the research with BrainHQ is going, is that most studies are using collections of exercises now rather than just a single exercise, because these exercises are really designed to work together to help improve brain function.
Yeah, it really is the science of neuroplasticity is really comprehensive, and so we tried to, as I imagine, create exercises that you know, tap into these different domains within cognition to help sort of elevate skill sets in those particular areas as well.
Yep.
All right, so Nita has a question. I'm going to paraphrase it here, but it seems like the issue that they're describing is that when training with right turn, the images aren't on top or aren't on screen for long enough for them to discern the differences between the two. They'll look at the first one and then not have enough time to look at the second one before it disappears.
Yeah, oh, sorry, go ahead.
Oh, they were asking, can the time allowed for comparison start out a little bit longer and allow the exercise to be more effectively done? Henry, go ahead.
Sure. No, it's absolutely right. They're on there for a short period of time. And part of the reason for that is, you know, if you had all day to look at them, I mean, let's say it was on the screen for 2 minutes, you would eventually be able to figure out which one was which, and you would get them all right. And of course, it doesn't actually train your brain to get them all right, right? If you get them all right, your brain doesn't need to rewire itself. Your brain's already good enough. So we make them fast to ask your brain to do this decision, to do this mental rotation at speed. And of course, like every BrainHQ exercise, if it gets fast enough that you can't quite do it, no problem. You're going to get it wrong. You can get it wrong on purpose if you're in the mood, and it will slow down again and find the right level for you. But, one more time for me to emphasize something that I know you talk a lot about in your role in customer support, Stephanie, which is, hey, it's okay to get something wrong in BrainHQ. It's okay to get it wrong a fair number of times. It's going to adapt to find the right challenge for you, and that's fine. So get it wrong a few times, it'll slow down, and you will be back on track.
Not a question, but Susan wrote in saying, I hated right turn at the beginning, but by doing it more and watching how things moved, I started to understand it, and it has helped me in driving. I did not expect that. So that's always a great thing to hear.
It is true. And I helped invent many of these exercises, but I'm in that same boat. There are a number of them that when I first started working on them, I, really didn't really found them very challenging and performed at a not too great level. And it is just remarkable what practice and effort will pay off. It's like learning anything. It's hard at first, but that consistent work on the exercise will eventually help you get better at it. And then, you may then start to see these changes in the kinds of everyday things that you do. So wonderful. Thanks for sharing that with us, Sue.
Yeah, absolutely. And I mean, Sue's comment kind of answered this next question here, but can you give some examples of how getting good at right turn would help in regular day-to-day life?
Oh, for me, I think when we designed this exercise, I'll just go back to that example. We thought a lot about like map reading. You imagine that you are, I'll give two quick examples. One of them is map reading. Imagine you're in a car looking at a paper map, or maybe you have Google Maps on your phone. And, the map is showing you how everything looks like if you are pointed north, and you need to turn right if you're pointed north. But out here in the world, maybe you're not pointed north, right? Maybe you're walking south, and you need to rotate that map in your mind to figure out what the direct angle to go is. So that's one of the big things we're trying to do with right turn. And imagine you're not reading a map. Imagine someone has just given you some instructions like that. Again, as you're out walking, you might need to kind of rotate the image you had in your mind of those instructions, so that as you're out walking to your destination, you make the correct right turns and left turns. So that kind of rotation comes up all the time as we're navigating things in the world right now.
Yeah, absolutely. It takes me back to the days, before Google Maps, before MapQuest, when, you would have to get actual directions where it's, turn north on First Street or whatever. It's less a problem now, but all the more reason to be working on that kind of skill set, I think.
Yep.
All right. So I think since we are a little bit crunched for time, let's go ahead and talk about Optic Flow next. So Optic Flow is the second exercise from the navigation category on our agenda for today. So Optic Flow works to improve your visual attention, detection of visual stimuli, and flexibility in poor visibility conditions. So it is similar to double decision in that it includes being able to notice features in your periphery when looking straight ahead and then being able to react to them quickly. So why is this important? Well, as we've already discussed, the ability to navigate safely through the world depends largely on your ability to notice potential hazards in your peripheral vision while simultaneously paying attention to the path in front of you. Henry, can you talk a little bit more about the design behind Optic Flow and why we included hazards and maybe how it differs a little bit from double decision?
You're right to almost think of it as a more advanced version of double decision. And it's definitely one of the most challenging exercises that's in BrainHQ, without a doubt. Whereas double decision is asking you to look straight ahead and notice things in your peripheral vision. And if you think about driving, you're looking straight ahead, maybe the car in front of you, you want to see if its brake lights come on, but you need to notice if something's coming into your right or your left, like a kid is stepping into the street. With Optic Flow, we're asking your eyes to do something more complicated. We're trying to give you a rule, something you need to do, like you're looking for the green triangle, and we want you to rapidly explore the visual field around you, and then notice where you see that as it's moving towards you. So it's more about moving your eyes around and rapidly extracting that information, whereas double decision, of course, is more about keeping your eyes steady in that way. And then all the things we introduce, there's kangaroos and the rain and the balls and all this kinds of tires floating around. All of that is just to provide what scientists call a little extra cognitive load. So it's extra things that distract your brain. And of course, what we want to train your brain is to be able to stay on target and stay focused on the thing you're looking for, like the green triangle, as you do it.
Yes.
I guess I'd say that's much like driving. I just got back from a trip and I did some driving in Istanbul, the capital of Turkey. And I got to tell you, it's a very complex driving environment. There's all kinds of crazy things going on at all times. And so you want to have that ability to, stay on target for what you're looking for, like a road sign or an exit or what have you. And, notice, but then ignore all the other crazy stuff that might be happening on the road around you.
Yeah, absolutely. So let's actually go ahead and take a look at what Optic Flow looks like when you're training with it. So in Optic Flow, you're going to be driving down a road. Like Henry said, you're going to see a target shape on a sign. There are going to be vehicles and various hazards that will approach you at different speeds. And then your task is to select the object with the shape that matches your target. So once you select the start button, you'll start driving down the road. And then you'll see this big overpass sign that will present you with your target for this turn. So for this example, it's a red square. Then you will continue down the road, and then there are going to be 4 marked objects in front of you across the screen and some additional hazards. So it's a little small here, but we can kind of see off to the left side, we have this green circle, we have a red square, we have a yellow triangle, and then we have a blue diamond, which is very, very difficult to see on that blue bin there. Then also off to the right, we saw a tire come in that's going to start making its way across the left side of the screen. Now, we will need to select a portion of the screen with the oncoming traffic, since that's where the red square is. So we'll go ahead and select that, and we get the little fireworks letting us know that we got that answer correct. So that is a very slowed down step-by-step version of Optic Flow. Let's take a look at what that looks like when we train with it in real time. All right, so I've got Optic Flow here. I'm gonna hit start. All right, so we're looking for a red circle, moving over to that first section and clicking it. Red square. Doing my best to ignore that turkey that's crossing the road. It sounds like the setup to a bad joke. And so we're going on and on and on and so on and so forth. Now, what happens if we get a question wrong? So it wants us to look at a blue square. Let's misclick. And it was kind of hard to hear the sound, but there was sort of like a little bonk there. There we go. Now, you can also get a trial marked wrong when you don't make a selection. So that is something also to be aware of when you're training with Optic Flow. So once again, not selecting anything, we get that little bonk sound. Now, one thing, there are a couple of tips that I do want to share about Optic Flow. So here, let me actually go back to the PowerPoint to sort of demonstrate that. So my first big tip for Optic Flow is that you don't need to use the mouse in order to make your selection if you're training with Optic Flow on a computer. So you can instead use the number keys along the top row of your keyboard. So all of our timed exercises have some sort of keyboard shortcut. That way you don't have to fuss with trying to move your cursor quickly and accurately within a time limit. And Optic Flow is no exception here. So we have these sections on the screen sort of labeled. So if your target image is in the first section, you would want to press the number 1 on your keyboard. If your target image was in the second section, you would want to press number 2, the oncoming traffic. 3 is the lane that you are in, the one that's going directly ahead. And then 4 is the side of the road on your side of the highway. So here's all of them sort of highlighted there for you all. Now, my second tip is to avoid selecting the top half of the exercise window. So sometimes we'll get folks who write into us saying that their inputs weren't accepted. I'm tapping on that side of the screen and nothing's happening. I keep getting marked wrong. And it turns out most of the time, people actually aren't clicking any of the valid selections on the screen. They're somewhere up in the sky on the top half of the window. So good news is that using the number keys across the top of your keyboard is also going to help prevent that issue from occurring. So next time you are training with Optic Flow, maybe give that a try if you find that some of your inputs aren't being accurately recorded.
I think that's so important, Stephanie, for exactly the reasons you laid out. It's better to use the keyboard really here if you can, because, with your mouse, it could be quite challenging to move your mouse all the way from one side of the screen to the other as quickly as you need to.
Yep, absolutely. All right, so let's talk about how Optic Flow sort of gets more challenging over time as well. There are a lot of dimensions for Optic Flow, which is one of the reasons why it can be one of the most challenging exercises for a lot of people. So first is that the target shapes and colors become more similar over time. In that first level that we demoed, we had a number of shapes and a number of colors. There are going to be some levels where all the shapes are the same color, or there are going to be some levels where all of the colors are different, but the shapes are the same. Now, the number and types of hazards that can appear will also increase and differ from level to level. So, we saw that turkey there. I think we saw one of the hawks and maybe an armadillo during that demo, but there are also deer and kangaroos, like Henry had mentioned as well, that sometimes walk across the street that you have to ignore. The backgrounds also become more complex and distracting. Again, talking about that contrast, having those, bright cars and those bright features along sort of a orange background is a lot easier to discern those details than it is against like a gray background. Now, the other thing is that you can get these backgrounds in both day and in night cycles. So that is one other way that it gets more complex. But in addition to that, it can either be sunny or it can be raining in Optic Flow. So it's, upping that cognitive load, as Henry was saying. It's adding more of those hazards. It's adding more of those distractions. Now, the other thing is that the exercise will also continue to adapt to your performance by reducing the time that you have to find the target shape. So as we saw when I was demoing it, the more questions that I answered correctly, the faster down the road I started driving, and then the faster those objects started heading towards us. All right, so let's go ahead and start taking a couple of questions about Optic Flow here.
Well, one thing I can say off the bat, Stephanie, is there are a lot of questions about those keyboard shortcuts. So I'm glad you talked about that. I think that's going to be helpful to a lot of people.
Absolutely. I just learned about that for the first time last year, and it completely changed the way that I interacted with Optic Flow.
I do think that deep in this engineering department, they're looking at a next round of help improvements eventually to try and highlight some of these keyboard shortcuts. So we all have that to look forward to over the next months, I think.
Yeah, absolutely. And later in the year, we actually are going to be running a webinar on accessibility options within BrainHQ. And our product development team has been redoing a lot of our exercises to include keyboard shortcuts for many of those exercises as well. So stay on the lookout for that. It's definitely on the forefront of our minds here. All right, let's see. How can I avoid the obstacles? Asks Leah. So good news, Leah. You don't actually have to do anything to avoid the obstacles in this iteration of Optic Flow. The obstacles are there just to distract you. You don't need to worry about running into them. Now, this wasn't always the case. This is actually an updated version of Optic Flow. In a previous version, you did have to actually press an extra key on your keyboard. I think it was the space bar to avoid obstacles that you were going to run into. Henry, do you want to talk about why we made that change?
We developed these exercises, and of course, our scientists have, pretty specific design ideas around how we are trying to train the brain with them. And, it made sense from a scientific perspective to ask for that extra response around the space key. But I think what we found out as more people start, and we always test these exercises internally with people at Posit Science and with test users. But I think what became clear is as more people started to use that exercise in the real world, that it made sense scientifically, but just in terms of the mechanics of how people had to use the keyboard and the mouse, it was just a little bit overwhelming to do the response. So I think it was scientifically well conceived, but just the how it got set up with the keyboard and the mouse was not really working the way we had hoped. So we pulled it back out for that reason.
Yeah. And I think we've seen a greater number of users who have started training with Optic Flow and stuck with Optic Flow because of that change. So it was a good thing to take into consideration.
Good.
All right, let's see. Fran is asking, oh, where'd that question go? Oh, I use my fingers on my iPad. I don't think I could get faster with number keys. What does your research show? So regarding using Optic Flow on an iPad, there are just going to be sections of the screen that you have to tap on. The webinar that we did last year, even though Optic Flow wasn't one that we went over in depth, I did demo it on the iPad. So I will at the end of the webinar, I'll go ahead and put a link to that replay, and you can check that out for yourself. As for research that it goes into Optic Flow, Henry, was Optic Flow ever specifically studied, or is it more of sort of that, part of a grouping of exercises that are used in the study at a time?
Definitely more part of a grouping of exercises like that. That's for sure. Sorry, just thinking about the tablet issue you were mentioning. I actually do Optic Flow mostly on a tablet myself. And, I do have to hold the tablet and really reach with my thumbs because, of course, we don't have those keyboard shortcuts. On the other hand, that's probably still faster and easier than doing a mouse on a computer. So if we had to give advice on that front, we'd probably say the keyboard shortcuts are the fastest. And then if you have a phone or a tablet, using your thumbs can also be quite fast to do the exercise.
Yeah, if you're holding the tablet in both hands, then 2 thumbs is the way to go. But if you are training with the tablet like on a surface or on a tabletop, you can use more than 2
That's true. You
fingers.
can almost touch type it, I suppose.
Yeah, kind of. Okay, so let's go ahead and move on to our last section here. We are going to be going over face-to-face. Now, face-to-face is an exercise from our people skills category within BrainHQ. It's designed to exercise what's called the social cognition network in your brain by pushing you to correctly interpret facial expressions. Now, Henry, can you talk to us what a social cognition network actually is within the context of the brain?
Sure. Often when people first hear about the brain, they hear that, hey, different parts of the brain do different things. And you may have heard, hey, you have part of the brain for processing your visual information and part of the brain for processing what you hear and part of the brain controls how you move your body. And all that's exactly true. But it turns out that the brain actually has very specific regions that are devoted to processing information about other people, which we think of as social cognition. And that's because as people, some of the most important things we interact with in the world are other people. So I suppose it makes sense that our brain devotes, quite a bit of processing power to that. So for example, there are specific regions of the brain that are only activated when a person sees other human faces. And there are other parts of the brain that are only activated in response to seeing emotions of various kinds. There are even parts of the auditory, the hearing parts of the brain that are specifically responsive, not just to speech, but to the emotional content of speech, whether someone sounds happy or sad when they talk to you. And so because all these parts of the brain are so important, we wanted to design exercises that specifically targeted these regions of the brain to make sure that we were training, well, as much of the brain as we possibly could with all of the exercises in BrainHQ. And so that was the inspiration behind this whole class of exercises. And between the face-to-face exercise in particular, there's just an enormous amount of really fascinating psychological science about, what happens to a face when a person is feeling happy or sad or angry or surprised or disgusted. It actually turns out that the facial expressions that people make are actually quite common across all different cultures around the world. You know, a person in North America or in New Guinea or in Africa, we all make the same facial expressions when we feel those emotions. And because that's such a core part of being human and a core part of how we want to navigate and understand the world, of course, we wanted to train those abilities.
Yeah. And just to sort of piggyback off of that, why it's important to train with exercises like face-to-face or any of our people skills exercises. It as humans, we are social creatures. That is very much built into us. And it is not only to our benefit, but to other people's benefits to be able to, read a facial expression, be able to react to it in a satisfying or savvy way. So that way, a moment can be satisfying instead of, socially awkward. These interactions add up to define our overall social savviness, comfort in social situations, and also helps with our self-confidence when we're around other people as well. So let's talk about the exercise. So in face-to-face, you're going to see a face that shows briefly on screen, and then you have to guess what sort of expression you think it shows. Then you'll see a set of faces, and then you have to choose the one showing the same expression as the first face you saw. So here, I'll go ahead and go back and we can sort of reset this and take it step by step again. So here we have a face of a person who is smiling. Then we get a little bit of a black square, probably Henry. Do you know if this is to help with image ghosting again or after images?
That's the idea again. So you don't have
Cool.
the after image.
Perfect. And then after that, we're presented with those three faces. So now we have to find the face with the closest matching expression to that target face that we originally saw. So let's take a guess. Gonna guess that one on the right, and we got it right. So let's do another one. So we have image there in the middle, it disappears. And then there are multiple images with different expressions here. So now we can select the face with the closest matching expression to the target. We're going to go ahead and guess that middle one, but we got it wrong. It turns out that the original target was maybe a little bit happier than we had anticipated. Now, you may be wondering why this got classified as the same sort of emotion. You might be wondering how we've determined what emotion matches each facial expression. Body language and facial expressions seem like they're subjective. So how do we go about classifying them? Henry, can you talk maybe about some of the science and the research that we put behind face-to-face when designing it?
Sure. As I mentioned, there's this incredible science behind facial emotion recognition. And on the one hand, it's incredible that these facial emotions are common across cultures and people all around the world. At the same time, any given image of someone's facial expression, maybe 90 or 80% of people will agree that this person is happy or neutral, but some people are always going to see it a little bit differently. And there's no objective answer. All we can do is try to create images that there's a consensus that most people view this, given the target emotion. The way we created these images is we actually had a scientist who specialized in social cognition. We actually recruited actors in San Francisco from different genders and ethnicities to come in to a photo studio. And as actors, we asked them to express emotion, right? What does it look like when you're happy? What does it look like when you're angry? And we actually asked them to express the emotions sort of mildly, moderately, and intensely, and then photograph them all. And then after we had all those photographs, we actually had an independent panel of observers rate each photograph and say, without knowing what the actor thought they were expressing, we had the independent panel of observers say, well, does this person look like they're happy or sad or angry or what have you? And does it look like they're really happy or just a little bit happy? And then we selected only the images of these actors that most of the observers agreed were expressing the target emotion. So we had to throw out some of the photos because they were a little bit ambiguous in the end. That being said, people still write to me and Stephanie on a, not uncommon basis and say, hey, I really think that person, the right answer was angry, but they just didn't look angry to me. And, I get it. We're all going to have slightly different impressions of that. And that's okay. Again, I'll just come back to a constant theme of training with BrainHQ, which is if you guess and, BrainHQ doesn't think you were right, particularly on these emotion ones, don't worry about it. Just keep going. It'll slow down. You'll go to the next one. You'll still be training your brain. It's not about getting every single one of these right. It's about training your brain with these stimuli at speed so you get faster, in this case, at social cognition. Does that make sense, Stephanie?
Yeah, absolutely. Thank you for sharing that. Let me go ahead and switch over to the demo window so we can see what this looks like in real time. All right, so we saw somebody with maybe sort of a grumpy face here. So actually what I'm doing is one of my tips for training with face-to-face. For face-to-face, I sometimes like to say the kind of facial expression that I think that the person is having or displaying. The other thing that I will sometimes do, and do this at your of your own will. I will sometimes also try and mimic the face that is the target face. So like if somebody is like smiling and really happy, I will try and smile and be really happy until I give my answer there. So the person before didn't look particularly happy. So I'm going to go ahead and guess here. And I got it wrong, but that's okay. Looked like they were maybe a little more miserable. That person is definitely miserable. So I'm going to go ahead and guess here. And we got it right. So let's do a couple more of these. That looked maybe neutral. Let's see. Nope, definitely sad. Yeah, you can see with the upturned eyes. Okay, so that is upturned eyebrows once again. Let's go sad for this one. And we got it right. Yeah. So you can see that there are a couple of, it can be a difficult exercise for sure. And you can see that, sometimes talking your way through it can also be helpful for some people. So let me go back to the slides here because I want to briefly talk about how face-to-face becomes more challenging. So more emotions get added into later levels of face-to-face. So, in early levels, you might start out with happy, neutral, sad, and angry. These, 4 pretty basic emotions. And then you can work your way up to levels where there are 11 different emotions that you can choose from. Now, the number of faces to choose from also increases. Levels within stage 1, you have 3 choices, whereas levels in stage 3, some of them have 5 choices or even more. Now, the view of the face can also change. It can be more difficult to determine somebody's expression when they are at a 45-degree angle or away from you, or if they're in profile, than it is if they're looking directly ahead at you. So that's another way that it gets more challenging. And then also, the time to view the target face is reduced. So if you continue to get questions correct, the target face will appear on screen for less time than before. All right, so let's take a couple of questions about face-to-face here.
Stephanie, I saw one question that I answered, but I'll mention it while we're live too as well, which is, hey, shouldn't we have more faces in here just so there's more? And shouldn't we have more faces of different kinds of people, older and younger, and of different ethnicities and all kinds of things? And the answer is, absolutely. These faces were originally photographed a number of years ago as we were first developing the exercise. And we're working right now on several different ideas about how we can significantly expand, all the kinds of faces that you see in this. We both want to be more representative of all kinds of ethnicities and racial backgrounds, but frankly, we just want to make the exercise more challenging as well. If you do this exercise enough, you're going to get to know a few of those faces, as I'm sure you know, Stephanie. And we know that if we had hundreds or even thousands of faces, it would be an even better exercise. So this is something we're working on in a very active way right now. Hopefully, we'll have some news about that next year.
Yeah, absolutely. I know that has been it's been a comment that we've gotten from some folks, feedback asking for more diversity in faces and gender representation. And it's always, it always pleases me to be able to say, hey, we are aware of the problem and we are very much working on it. All right. There are a lot of questions here. Is this the same as face facts? No, face facts is a different exercise in our people skills category. Face facts, I believe, is the one where you are shown a face and then you're given 3 facts about that person. And then you are given a quiz about which facts about that person are actually true. So different exercise, but same category. So you're in the right area. All right, so I think that's going to wrap it up for face-to-face questions. Henry, are there any other questions in the Q&A section that you wanted to take an opportunity to answer before we start wrapping up?
No, I know there have been quite a few, and we've answered as many as we can live, and we've answered quite a few more just sort of in the chat window. I know we never have a chance to get to them all, and it's wonderful to have so many people have so many interesting questions about BrainHQ. So I'll just emphasize what you had started off with, which is I hope we got to your question. I know we didn't get to all of them. Feel free to just email us at support@BrainHQ, and we would look forward to taking them further at that point.
Yeah, absolutely. Webinar ran a little bit long. We got a little too excited about the science behind some of these exercises. So we didn't have an opportunity to answer questions about other exercises outside of these 4. But what I will go ahead and do is hang back in the chat box after the webinar presentation ends, and then I'll be sure to put a link to all of the resources that we've talked about, the webinar from last year, where to find the recording from this year, where to find our research studies, so on and so forth. So if you all want to hang out for a couple minutes after we wrap, I will put that all in the chat for you all. All right. So once again, apologies that we didn't get a chance to answer every single question, but we thank you all so much for participating in today's webinar. Next month's webinar is going to be one that I am personally very, very excited about. It's called The Value of Neurodiverse Brains and How BrainHQ Can Help Them Thrive. That will be taking place on October 18th, and that's going to be run by our very own Dr. Atara, returning to the webinar scene. Let's see here. Well, once again, my name is Stephanie. I'm a customer delight specialist here at Posit Science. Henry, do you have any final words that you would like to share with our audience today?
No, except thanks for coming to this webinar about tackling the most challenging exercises, and I wish everyone happy brain training. We're delighted to have you as BrainHQ users, and look forward to staying in touch with you as you keep training your brains. Thank you.
Absolutely. Stay back and hang in the chat if you want those links. Otherwise, I hope you all have a wonderful rest of your day, and happy brain training to you as well.
Bye-bye, everyone.